classes and we were really starting to talk about this idea of object-oriented programming. And the whole point of this is that in programming, class is something that models state and behavior. And of course, I'm going to put this in your Slack channel later so you have it. And so when we describe this, state is what something is. And behavior is what something does. So the example that we gave during our kind of warm up there, that we had our class as a refrigerator. We talked about the state of the refrigerator being the brand of refrigerator is, the color of the refrigerator is, and the temperature. Right? These are things that tell us something about the refrigerator itself. The behavior, what refrigerator does, is that it adds foods, removes foods, and changes temperature. Right? And so we use these words, an instance or object is a concrete representation of a class. So when we think about it, right, like we have a refrigerator in general is a type of object, but we also want to refer to like specific objects. So like when we think about a generic object like a car, right? But at the same time, like I may have a car, you may have a car. They're both cars, but they're different, right? Like mine may be blue, yours may be black. They're not the same one. Right now, like the two terms are interchangeable. And how we kind of differentiate these two things is like we can imagine one is like a blueprint and one is an actual thing. So going back to that vehicle, the engineers at any car company, they have the plan, this blueprint to make cars. And from this blueprint, they then make individual cars. And these individual cars may have different states, like they may be different colors. Eventually, they're going to have different levels of gas in them or whatever. The air conditioning may be set at different temperatures, but they all come from the same place. So in general, when we in our code, we use objects and we create these like object blueprints in order to make our life easier, in order to kind of like wrap our heads around what we're doing. And so the syntax of that is going to look something like this. It's going to be class, name of class, end, right? And so, for example, if I became the software architect for a dog shelter and I needed to model dogs, I would do class, dog, end. I want you to note that we're using upper camel case for the class name, so that if you have a class name with more than one word, the first letter of each word is capitalized, and that's called upper camel case. And upper camel case in upper camel case is cool. Questions at this point about classes, objects, instances of? It's okay if you don't have much. We haven't talked about much about it. We will get into further detail. But Jordan?
Yeah, I was just wondering, is upper camel case the same as Pascal case?
Not sure. Let me look that up. Everyone, looks like the thing is that there's different words to describe the same thing. Yeah, Pascal case is the same thing as upper camel case. It's like different names for the same thing. I actually don't really remember this. I have to look it up each time. I just know what I need to do, and I don't remember so much the name for it. And so, like, yeah. Cool. All right. So let's go over a class example of like how this kind of looks, right? So I've already created a unicorn.rb, and in here I've got this. I'm just working this directory I made a directory for this class, and I've made a unicorn file. And so what we're going to do is that we're going to put this unicorn class in the unicorn file. The one thing I want to note is that in general, what we want to do is the name of the class should be the name of the file. If I'm making a unicorn class, the name of the file should be unicorn.rb. The main reason why is that like it just kind of makes sense. The idea, I think the big picture, what I always say is like good advice for writing code is that you're not writing code for like now, you're writing code for the next person. And that next person may be the new engineer on the team. That next person may be you 6 months from now. Because I can guarantee you, you're not going to remember a thing you did 6 months ago. And so like the idea is like, hey, I'm going to make Future Mike's job a lot easier, because Future Mike is great and he's going to take care of it. Sometimes past Mike is a jerk and makes poor decisions, but we're not going to hold that on him because he was doing the best he could at that time. So like kind of give you an example, right? If I were making a unicorn class, I would not put it in like pizza.rb. Like, no, like why would you do that? Or like that just makes things, you're adding like an extra layer of difficulty to the whole process. And like, no, like the name of the class, we're just gonna put they're gonna share the same name. So a person that's looking for the unicorn class is like, oh, it's gonna be unicorn.rb. There's no surprise. It's like, it's called the principle of least surprise. You want to do the least surprising thing. Other things you want to do, like don't like number your files. I've seen people do this. Like unicorn class goes in 1.rb, the next file goes in 2.rb. Like, no, don't do that. You'll just have the names match up. It just makes everyone's life a little easier. All right, so we're just going to do here, we're in the unicorn RB, and we're going to make a unicorn class. Let's save it. And we've created this class in here. So what we're going to do, excuse me, is that I'm going to make a runner file in here. I'm going to put it over here. Oops. And it's going to sit over here. And I'm going to do this. When I type, I will also generally stop talking because I cannot type, think, and speak at the same time. So it's okay if you don't hear me talk while I type. I have trouble I can also have trouble doing that head pat, rub stomach thing at the same time. Cannot do that. So what I want to do is that I'm going to run the the runner file from my command line by typing in ruby runner.rb. Cool. So what's happening here is that when I run this file, our terminal is opening up a pry session where it runs when it hits require pry binary pry. And what we can do is that we can access unicorn 1 and unicorn 2. What's happening in this file is that this required unicorn is telling Ruby like, hey, the / means in the directory I'm running it from, I want you to load and I want you to make available whatever is in the unicorn.rb file. The RB is implied here. It's just going to look for an RB file with the name unicorn. It's like, great. So now essentially what you can imagine is happening behind the scenes is that it's essentially copying, pasting whatever's in here and we're putting in here. It just doesn't happen that way. Like the idea is that we want things in separate files for organizational purposes. The idea is that we want to stay organized. Like you might think like, hey, we're just doing the unicorn, why don't we throw the code in here? Like, yes, you can do that. But the thing is that you're not going to be continually working with like Ruby code that is just 5 lines long. Essentially, you'll be potentially working on classes and objects that are 100 lines long. We want to keep things organized possible. Here with the unicorn 1 equals unicorn.new, we're instantiating new instances of the unicorn object. So to go back to that kind of car analogy, this unicorn class is our blueprint, and this is kind of like our factory. What we're doing is like, hey, we're making a new unicorn from this blueprint. We're making a second new unicorn from this blueprint. And this require pry binding.pry. What it's doing is that it is opening the pry session in the context of this, in the context of this file that we're running. And we can see here, we can access these two instances of unicorns. Right. So Adam, what's the difference between unicorn 1 and unicorn 2? You are muted. Still muted. There you go.
Sorry about that.
Right.
They come from the same class, but they're literally different objects, even though at this point there's no attributes to really tell them apart. They are in different places in memory. So if you did something to unicorn 1, unicorn 2 would be unaffected.
Yeah, that's a great answer. Going back to the car examples, it's as if you had like 2 identical cars roll off the factory line with the same kind, with the same color, same features, same options and everything. Like, yes, they are identical. They are both cars. They are both the same model. All the attributes match, but they are different things. Like I can go drive one off and someone else can go drive one off. Fantastic. So what we've done here is that we've created this unicorn class, and we've created specific instances of the unicorn class that we are holding in the local variables unicorn 1, unicorn 2, right? And so we can kind of make it so that what if we want to give them names and have them be different colors, right? And what we do is that we often use what are called instance variables to model attributes in code. And what we do is that we define these instance variables in a special method called initialize that is run every single time a new instance of a class is created. Let me go back to my notes here. We'll go down here. Right. We model attributes in code using I'll make a note here. Be very careful on how you spell initialize. You will waste at least a couple of hours of your time trying to figure out something that works because you spelled initialize wrong. That's just what's going to happen. Like you will do it, I will do it, everyone has done it. You will spend about half an hour and you'll realize because you probably left out an I or swapped out. So like every single time I type in initialize, I just say it out loud to make sure I didn't mess it up. And so what it does is it often goes in here, def in it eyes. And so the thing is that whenever we instantiate a new instance of an object, initialize will run. One way you can think of it is that new is just a kind of an alias for initialize. They do kind of the same thing. This method is run once and only once. So what I can do is that I can do let's for example puts I am alive. And when I run this again, You can see it's printed out twice. Oops, let me scroll up a little bit because I've created 2 instances of this unicorn, and it will be alive. So again, the initialize method. No, why did you make yourself bigger? I did not want you to be bigger. Once and only once when new object is instantiated. Hey, calm your butt down. Whenever someone walks across like my door, my dog starts barking. This is the only time she ever barks. It took me like 2 weeks to realize she's a dog that barks. Very possessive of my apartment. But anyway, questions about initialize so far. It's kind of half the story. So we go back to here. When we come back to here, it's like, how useful are these unicorns so far? Harrison, how useful?
Since they don't have methods, or they really just
don't have methods.
initialize.
Yeah, they don't do anything, right? We can't even, it's very difficult to tell them apart, right? So aside from their object ID, like, which is like, when we type this, we can see their object ID, right? Like there's no real difference. There's no way to differentiate them too. And like when we go back to what we said earlier, classes are supposed to model behavior in the state. And so what we're going to do is that we are going to give unicorn some state. So what we're going to do is we're going to add some attributes to this unicorn. And what's going to look like this. Let me get rid of this. We don't need to do that anymore. I'm going to do this. And let me just push this aside a little bit. Give myself some room. And what I like to do is I like to line these up so they are nice and clean. So I like lining things up. I feel it makes it easy to read. People have different thoughts about it. And so what we're doing here is that this, we've set these things here. We have this @ symbol here. And what this @ symbol before a variable name indicates is that it's an attribute or an instance variable. @ symbol before a variable name denotes that it is an attribute or an instance variable. These two terms are interchangeable, but I refer to it as an instance variable because that's what any variable name with an @ before is called an instance variable, and I default to using that nomenclature for it. And so what we're doing here is that we're saying that this initialize method is going to now take 2 arguments. And these 2 arguments, these parameters, are now going to be stored as this instance variable name and color. This is name parameter, color parameter. Usually I don't like using the word parameter. So what I'll do is that I will just shorten this to name and color. I think it's a little more, I think the parameter is redundant because it is going to be, of course, it's a parameter. And so it'll look like this. So when we run our code now, let me go ahead and quit out this prize session, and we will run it again. It's going to complain that we have initialized wrong number of arguments, given 0, expected 2. And from yesterday, what did we talk about when we came across this error message yesterday? Chris with a K. I don't even know if there's Chris with a C in here. I'm just gonna.
It looks like the method initialize is expecting 2 arguments. So when we create a unicorn, we have to pass it 2 arguments. So.
Cool, fantastic. So what we're going to do is that we need to like start passing arguments to this. So the first one was going to be Sparkle. It's going to be the name. And its color is going to be rainbow. And the second one, let's say the second one doesn't have a name. So we do have to pass an empty string. And this one is going to be a white unicorn. So make sure I save all my files. Cool, cool, cool. So when we include arguments to .new, Ruby is going to like say, oh, okay, I know new is the same thing as initialize. So it's just going to pass those arguments to initialize. And so I also want to note, I also want you to make sure you see that like these arguments, the order does matter. So like Sparkle, because it's the first one, that's what goes into name. Rainbow is the second one, that's what goes into color. Like the order is something that definitely matters here. And so Sparkle is going to be the name, Rainbow is going to be the color for the first unicorn, for unicorn 2. This is an empty string, so the name is going to be empty and the color is going to be white. And so what we've done here is like, this is a very common pattern. We gave our initialize method some arguments, and then we are saving whatever comes in through those arguments to instance variables. And instance variables are these variables that have the @ symbol in front. This is a pattern that happens a lot. You're going to be doing this a lot. And it is, although this is something that we see often, it is not like a hard and fast rule. There are very few hard and fast rules. For example, you could possibly set a default value in your initialize that it's not coming as an argument. For example, we have magical powers because unicorns are magical. And we're going to set that to an empty array. And what we're saying here is that, hey, a unicorn by default has some magical powers. We're just not going to give the magical powers to the unicorn by default. Any questions at this point about what we've done, about setting instance variables, about kind of setting these attributes? We haven't talked about behaviors yet. So like, you know, don't worry about that part. But I just want to kind of open up to questions / discussion about what's happening here. Will?
Yeah, I was just wondering, because yesterday we were calling that .new without an initialize defined.
Yep.
So just because you were just saying that it takes that .new and passes it right to initialize, what is it doing when there is no initialize?
Yeah, so when we don't have initialize, it just looks, it's still there. It's still kind of there. It's just like, oh, there's nothing there, so it does nothing.
Okay.
It'll kind of check to see if anything's there. It's like, oh, there's nothing in there. We're just gonna pretend everything's okay.
Got it.
Cool. Genevieve?
Yeah, I was just curious, when you're calling upon the unicorn file, just the / is it because it's in the same directory?
Yes.
That it knows that if you had it in another folder, you would have to specify?
Yes.
Okay.
The / is generally is a general nomenclature saying like here where you are running this file, like in relation to here, I want you to look for the thing.
Gotcha. Thank you.
No problem. Trevor?
Just a quick question. Is the object ID just like a randomly generated number? Is it being created from some specific thing?
I believe it's a memory address of where the object lives in memory. You are probably never going to use that information. It just needs a unique. It just needs some kind of unique identifier, and that is generally unique enough. It doesn't cause any problems. Yep.
Cool.
Cool. Awesome. Jake.
Yeah. So on the runner.rb file, where you have the require pry semicolon binding that pry. If you didn't have that, could you still open both in one pry session because you have the require /unicorn at the top?
Can you just say more about like what do you mean by open both?
Let me just rephrase the question. What does line 6 require pry semicolon
Mhm.
binding that pry. What's that doing?
Yeah, so binding a pry is opening up a pry session. Let me just run it right here so you can see. Right there, right? It requires, it pretty much says like, hey, when I hit this line of code, I'm gonna insert a pry. I'm gonna open up pry in the context of where I'm running this code.
Okay, so you're
Right.
essentially you're running it through the terminal, and then when it gets to there, it's telling the terminal open a pry session.
Yep, it tells it stop, open a pry session, but with the context of everything I've done. So I still have access at Unicorn.
Okay,
Right?
and if
It's a way for you to kind of like pause execution of your code and kind of check to see everything that's happening, rather than opening up a pry from the command line and then copying and pasting all your code in.
and
right,
if there's
so
code
in-
below it, it wouldn't be in
Mhm.
the pry session.
It
'cause
would not. So
Right.
like for debugging purposes, like if there was something wrong with Unicorn 1, I can move my pry between the two and take a look at what's happening there.
Got it.
And
Cool.
we'll go into a little more depth about debugging a little later on.
Cool.
Joseph?
Yeah, I was wondering if you could answer why my pry needs code below it in order to run. I was wondering if you know why that happens.
I do not. Let's put a pin in that and we'll come back to
Cool.
it and take a look at that outside of class. Cool. Awesome. This is a good time for a break. Let's take a break. Let's see you back at 9:40. Let's see you back at 9:40. All right. It looks like everyone's back. And so I'm over here and let me just quit this to make sure that I'm running fresh. Cool. And so what we've done here is that we've added some attributes to this Unicorn class, and kind of like the big picture is like, hey, like now we have some differentiation between them all. And now that's great, right? That's kind of what we want. We want to be able to use these attributes. So what we can do here is like, oh, let's get access to them. We want to do something with these attributes that we created, and like the idea is it's kind of like if a tree falls down in the woods and no one's around here, did it really fall? Like these attributes are here and they're great, but like these attributes do nothing for us unless we can access them, right? And so generally the way that we access information stored in a class is by sending it messages or calling methods in the class, and we use that using the dot syntax. So let me put this down here. The way in which we access information stored within a class is by calling a method on that class. Cool. So the idea here is that I want to make methods that will give me information about these particular class objects. And so how I want that to work is that, let's say I want to do this, unicorn _1 dot name. I want to make a name method for it that will return me that unicorn's name. And I'll hit enter here, and it says undefined method name for unicorn, for that particular unicorn. The syntax here is correct, but we haven't told our unicorn class what to do when we want to run a name method or receives the message name. And so we could do that with methods like the ones we've seen, but attribute stores and instance variables are a little special. And so what we do is we want to create these reader methods. So we go here. Like that. The error message says we do not have a method called name. So we are going to create a method name, and it's going to return the contents of the instance variable. And I'm going to go ahead and do this again for the other ones. Oops. Color, and it's going to return at color. Def. Powers. That's going to return magical powers. Cool. And let me quit my run file, run it again. And when I do unicorn _1, oops, dot name, it returns a sparkle. So what we do now is that what we're able to do now is we're able to call unicorn underscore one dot name, and we get back whatever was stored in the instance variable. And these are what we call reader methods because they are methods which read the information stored within the object. But what's the problem with doing it this way? Erica? What do we not like about this? You're muted.
Oh, sorry. I'm not entirely sure, to be perfectly honest.
That's fine. What happens if we have more than 3 attributes here? What if we have 5? What if we have like 20? We can see that this is going to get real long real quick, right? Essentially, we're adding 3 lines of code for every single attribute we want access of outside. So there is a special syntax for calling these attribute readers. And so what we're going to do is up over here, you do adder reader, and we use a colon name. Color, magical powers. And when we do that, we can delete these. What I've done is that using this adder reader special syntax, we've taken away, it has replaced these reader methods that I've created for myself. So I'm going to prove that, oops, by running the runner file again. And we can see that unicorn one dot name is sparkle, unicorn one dot color is rainbow, unicorn one dot magical powers is that empty array. Unicorn two dot name is empty string because we made that empty string here. Unicorn 2 color is white, and so forth and so on. I want to open up for questions / discussion about the adder reader syntax, the creation of reader methods and the replacement of those reader methods with the adder reader syntax. The adder reader syntax, again, is just a kind of a shortcut. So like we don't have to create methods for every single one. We just list it there. It'll do it for us. Kyle?
Could you give an example of a time when we would create an instance variable that we would not want to be able to read? Or is there also,
yeah,
or another way would be, why wouldn't all of them just be adder readers by default?
That's a great question. So like you would only want to expose things externally as you needed to. A good example is like something that you want the class to know about, but only the class to know about. I think an example of this is like, let's say you're running the witness protection program for the FBI or whatever, and you want their new identity to be only visible inside. The idea is that my rule of thumb is like there's something called the principle of least privilege, is that you should only expose things you need to. So like by default, I would not automatically create adder readers. I would only make things visible to the outside as I needed to, as I went along. I would not automatically create adder readers for everything. Cool. Awesome. Regina?
So what does it mean? So let's say you have unicorn_1, unicorn.new. What does it mean when you have something in what's it called, in that list, but it has a colon before the word? So it's not a string, it's not a
It's called a
integer.
symbol.
Okay. Oh, okay. So it literally
Mhm.
means a symbol. Okay.
Yep.
Okay.
When you put a colon in front of something, it says it's a symbol.
Is that how it
And
comes? Is that how it comes? How does that? So just telling the computer that it's a symbol, or
yeah, it's saying that like, hey, when I do this here, I want you to create a method called name that returns us that that at name. It's just kind of like it's what's called syntactic sugar. It's just like a shortcut to kind of save us time.
Okay, thank you.
Yep. Doug?
What's the difference between adder reader, adder writer, and adder assessor? Because they mentioned that in Mod 0, but didn't explain.
Yeah. Adder reader is being able to read everything. You have like the ability to read things from outside the class. Adder writer means you can change things. You could change the value of the name from outside. You can change like you could change the name from Sparkle to Charlie, right? Adder accessor is a combination of adder reader and adder writer, and it gives you access to both. I've never actually used adder writer. It's always been accessor or reader, because it's like they're the use case for where you'd be able to have access to change something but not know what it is like really, really narrow. There's just not much kind of, it's like the only real world analog I can think of like being able to change something but not actually know what's in there is kind of like a mailbox. Like you can put your mail in there, but like once you put it in there, like you don't know what else is in there. You know, like it's just kind of locked off to you. That kind of thing isn't something that happens too often.
So the attribute, the adder reader, writer, whatever, that's all for taking place outside of the class. So if I wanted to say inside the class, I don't need that, and I can make all the changes I want. Outside the class, I need. Okay, makes sense.
Yeah, and in general, I generally refrain from using adder accessor too much. I generally don't want to give that access to anyone else. I try to make it habit. I think it's a good habit to not to get used to not depend on accessor so much. But we'll kind of get into that a little bit. Cool. Other questions? These are great questions. These are fantastic. So, like, really digging deep. Joseph?
Yeah, where does adder reader and adder accessor live? Like, you know, there's a string class and it has its specific methods within it, or an integer class and it has specific.
Not sure, but I would say it lives in an object somewhere.
Okay.
That's because as you go up, like most everything inherits from objects, so I think that's where that lives.
Okay.
Cool. Awesome. Any other questions about this so far? Jake?
You just have them on separate lines for like easier human readability?
Yeah.
Okay. But they could all be on one line.
Yeah, they could. Don't do that though. Generally people put in multiple lines because it's like it's really super easily. Like what people generally do is that the order these come in are generally the order that they appear here in your initialize. Because it's kind of like, I think that when you pick the order that things come in your initialize, you're also assigning kind of a value. Like generally people put the most important thing in the front. Some people alphabetize, and that doesn't feel right to me. It just feels like very like arbitrary. Like, why are we alphabetizing it? Like, it makes no sense. I think that there's a value, there's like some kind of value judgment in like what comes first. And so usually this will be in the order of whatever we pass in the nest. I personally think the alphabetize people are like psychopaths. Like, why would you do that? You're just making work for people.
And just by keeping one space in between is for easier readability. Like you don't need an end at the end of attribute reader.
No, there just is no end.
Right.
Because essentially what's happening is that adder reader is a method that is like that. Except for like, so this is like one of those things where I've kind of said like we generally want to use parentheses when we're passing arguments, but adder readers is one of those methods where we just don't. and just someone decided like we just don't do that, and like everyone's like, okay, we don't do that. I think it looks better that way, but like I think that is also a like kind of a value judgment. Like someone decided it looks better this way, then everyone says, oh, that's the way we do it. And I think that it's gotten to this point where if it isn't that way, it just kind of looks off to people that are used to it. And that's just the way it is.
Cool.
Awesome. We've gone on for a bit. Let us take another break. Let's be back at 10:15. Let's be back at 10:15. All right. Put my notes. Cool. So what we've done here is that we've created some methods. Oh, Regina, do you have a question?
Yeah. I don't know if I'll be able to ask this over here but we keep getting like this syntax error, and it has something to do with the parentheses within the quotes in between the parentheses. And I get that on my homework too. So we say there's a string for name. It's coming up something between the parentheses or the comma, but the syntax looks right.
Yeah, can you post that in the Code Up channel? We'll take a look at it after class.
Okay, sounds good. Thanks.
Awesome. So as I was saying, we can also create other methods, right? We've created methods that kind of read the thing, but we can create other methods that allow us to do other things with the Unicorn class. So right here in the Unicorn class, we see that we have like magical powers, which is just an empty array. So what we can do is that we can add powers to it, right? So what we can do is that we could do like a def add power. Oops, there's no Q in power, and it's going to be a power. And essentially what this do is that this will modify our magical powers. And what we're going to do is magical powers, and we're going to shovel in the power. And what this does is that whatever argument comes in as power, we're just going to add that to an array. So we've updated this, and what we're going to do is that over here, before I bind up pry, what I'm going to do is, what kind of power? Unicorn 1 dot add power, and I want Unicorn 1 to be able to shoot sparkles. And I'm gonna run it. Okay, so we see that Unicorn 1 dot magical powers includes shoot sparkles, right? It has that in there now because I've gone and added power shoot sparkles here. I can continue to add other powers. Unicorn 2 dot add power fart glitter. That feels like a power that a unicorn should have. And so when I do Unicorn 2 dot magical powers, we see that the unnamed Unicorn 2 can indeed fart glitter. And note how Unicorn 1 can shoot sparkles and only shoot sparkles, where Unicorn 2 can only fart glitter. Kyle?
When you're using an attribute in a method, does it matter if you have the @ symbol in front of it or not?
Generally, it is a. Generally, I like to do that because it's very specific what I'm trying to accomplish. Because I see that there's an @ symbol here, then I know that like this is going to be, we're accessing the same thing. I'm trying to be like internally consistent. I like things to match up, and so I will do that. I think so. I believe I also read somewhere it's slightly faster if you do it that way. Cool. Other questions? Trevor?
Up at your magical powers attribute, you have an array for your variable. Could you just use single quotes? Or do you have to use the array brackets?
Yeah, so you could use whatever you want. I picked an array because I want to open myself to the potential that I could have a series of magical powers. If I were to use quotes, and I will say that I want there to be one magical power, I could do something like that quotes, like you say.
Mhm.
And this here, I would set this to equal, right?
Got it.
But yeah, like you can do that. Like I made a design choice that I wanted there to have potential of more and more multiple power. So like I could do unicorn 1 dot add power shine brightly, I guess. Don't really know what. Yeah, and you see here that unicorn 1 dot magical powers has the 2.
Got it.
So like the other one works. This is just the design choice that I made. Cool. Other questions so far? All right. So I also want to mention that like the idea is that like classes don't live in a vacuum. And when we build more complex programs, we have many classes and these classes can interact. So let's say we can actually modify this. So I'm going to kind of abstract this out a little bit, and I want to make a power object. So touch power.rb. And I'm just going to copy and paste this to save myself the time typing. And I'm just going to pause right here so y'all can take a look what I've done. I've made a power class where it has a name and energy required. And we're able to read that information from outside the object because we have an adder reader here. And I'm going to, essentially what I'm going to do is that I'm going to add power objects to this unicorn instead of having strings. So that means I need to change my stuff over here in my runner file. So in addition to requiring unicorn, I'm now going to have to require because I need to load up that file. And I'm going to create some powers here. So it's going to be power, whoops. Power 1 is going to be power.new, and this is going to be shoot sparkles. And we know that it takes 2 arguments because we defined 2 arguments over here. Let me just pull this over to the side a little bit to make it a little easier to read. Energy required, I mean, 1. Sure, like no real reason, no, just arbitrary. And I'm going to make a second power. This one is going to be the fart glitter, and fart glitter, that takes some effort. And we're gonna have a 5. And I'm just gonna give myself a little space. So I'm gonna break this up a little bit, give myself some white space. Let me just make a just a blank line there so I can kind of like see things easier. And unicorn 1 is going to add power 1. Unicorn 1 is going to add power. It's going to add power 2. So Sparkle is going to be able to shoot sparkles and fart glitter. And when we run this, we can see if we just type in unicorn, oops, 1, we see it has these attributes. When you add attributes to unicorn and you just kind of like put things out, when you just kind of like access it, you see all the instance variables. And when I do unicorn 1 dot magical powers, I will see that I have an array of power objects now that have their own attributes. And so if I wanted to access the first one, hey, call your butt down. I can do unicorn. If I want to get the name of the first magical power, I go unicorn 1 dot magical powers. And because this is an array, I'm going to grab the first one. and then I'm going to grab its name. I'm going to chain things, and I can see I have shoot sparkles. So now essentially what we've done here is that we've replaced the string of these unicorn powers into power objects, and we've added these power objects into the unicorn class. Let me pull this over here so you can see the two side by side. Actually, let me split so you can see all three. I need to make this a little smaller so it'll easier to read, but we can take a look at it like this. And this is a pattern that you're going to be working with continuously. It's very much similar to those Russian nesting dolls, where things live inside things that live inside other things. I kind of want to open it up to questions right here. Like this was a conceptual leap. Kyle?
When you put an object inside of another object, can that only go within an array that's contained in an object?
No. Like we said before, we could have just set this like magical powers equal to whatever, like we'll just call it a string. And if here we set this just to equals like that, it will only have one power, and that will work. I've only built it to an array here just because like I want the idea of like I want to have more than one power. I want to have to give myself that ability to have more than one power. The idea of like things containing things like and like this is probably one of the more difficult things about programming. This is why when you interviewed that logic problems that we made you do, that logic problem is really a big test of how many things you can hold in your mind at the same time, and how you can make them relate to each other. Because this is what you're gonna have to do. You're gonna have to figure out like, okay, in this essentially this chain of Russian nesting dolls, where am I? What objects do I have access to where I'm interacting to? Like this is just 2 levels, but like essentially this can and will get more complex. And the ability to kind of like hold and think about multiple things in your head is like, I think is pretty important programming. Jake?
Okay, so we have the unicorn object, which now has the power object inside of it.
When we've added to it, yes.
After we've added to it. But both methods or both classes can have their own methods.
Yeah.
But just because the power object has a certain method, an instance of the unicorn class couldn't necessarily use that method. It can only after the power instance was added to it. And
yes.
Through like if you tried to use like unicorn's color attribute with a method from the power class, it wouldn't be able to. It would have to be within the object in there.
Bingo. Yeah, there's a definite hierarchy about it. Right. Like usually you can only travel in one direction unless we're going to talk about how you can travel in 2 directions like week 5. But like right now, like understanding that like you can reach through in one direction is like super important. But that's a really good point.
Is that future thing we're talking about inheriting?
Not inheriting.
Okay.
It's a different technique we're going to talk about later.
Okay, I'll table it for now.
Yeah. I love just cliffhangers is my thing.
Cool, thank you.
Tommy.
Yeah. So, a object of one particular class could be an attribute of okay, cool.
I think like what we want to think about is like everything in Ruby is an object. I think that's because like when we think about it, when we have the name here, that's a string, right? A string's an object. Like we're already working with objects everywhere. It's just that I think that as students, when we first get to it, it seems a little unnatural because we are now talking about objects that we've created. Like it works the same exact way. Like the string object, like the name, like Sparkle here, is exactly the same as like the power object. It's just that we're the ones creating it. And I think there's like this disconnect. Like it works the exact same way. Like string object has methods, like we talked about yesterday. There's an upcase method, downcase method. Like those are just methods that we get for free with the thing. But now we've taken this a step further where instead of working with objects that Ruby's given us, we're now creating our own objects to do that. But yeah, we are still working with objects, still works the same way. Katie?
Hi. So my question is actually in the pry session that you had when you did Unicorn 1.
Yep.
Why
We'll do that again.
Yeah. I was just curious as to why we're seeing the power to like the energy required 5 and the fart glitter for Unicorn 1.
Yeah. Because I've added that to Unicorn 1.
Okay.
So let me kind of like go through this step by step so we see it visually. What I'm going to do is that I'm going to call unicorn equals unicorn.new. Oops, what am I doing? No, I need to pass it things. It's going to be Charlie. Does anyone remember Charlie the unicorn?
Yes.
We see here we have this unicorn object. It has a color, it has a name, it has no magical powers, right? Magical powers is a empty array. Do we see that? Right. So what I'm going to do is I'm going to make a power. Power equals, oops, power.new. It's going to be get candy. Energy cost is going to be 1, right? And so we see power there, unicorn. You know, power is that. Unicorn is that. No relation between the two, right? Now, what I'm going to do is that unicorn.add power. And we see here that it has a color, but the magical powers array now contains a power with the energy required 1 get candy, right? Because it is inside of it now. And this is how you can tell what's inside, but I think that like it's not a really good idea to like just look at the object like this to figure out what's happening, because as you add more objects to it, it gets like super long.
Yeah.
And, like super confusing.
I see what I did. I was like, when I was looking back at your code, you have unicorn 1 for each, and you did unicorn 1 add power for the second line, just above the require. I had unicorn 2, and that's why I was like, how did you get both of these in both of these powers into unicorn 1? So I figured it out. Thank you.
Awesome. Yeah. So like usually I don't like looking at like this entire way. What I want to do is that when I'm looking at an object, I want only the information I want. So if I just want the information I want, if I just want to look at the powers, I do unicorn.magical powers. And then I see that. You always want to deal with the smallest set of information you can get to make sure like you're not confusing yourself with anything else. Cool. Other questions? Comments about what we're doing here? Erica?
Yeah, I just am still trying to understand how to use pry. And so in this, when you were just explaining that, you added a new power and you added a new unicorn.
Yeah.
But those only exist within that pry, and they don't like, they're not a permanent change.
Yes, they're not a permanent change, right? Yeah, so like that's kind of like the power pry, is that I could do whatever I want to test things out without having any impact on my code.
Okay.
And so like often, like as you're doing, as I'm working on like solving problems or stuff, I don't know how to do something. I'll just open up pry and play with it. Like pry is like just like the sandbox. I think that new students to programming have this fear of like, I don't know what I should do this. I'm like, code is free. Like it just takes you the effort of typing stuff out or even just deleting it. Like, don't be afraid just to try it. Like, I think that I think that trying something just out of just sheer curiosity is like super powerful, because like not only like I think that everything you do is valuable in the fact that like, hey, you learn like, well, this doesn't work. And like, I think that learning that something does not work is just as important as finding out something that does work. Or using something in the wrong way to achieve a goal is like super critical to understand it.
Okay, thank you.
Yeah. Trevor?
Is that the difference between pry and IRB? Does IRB actually commit the changes?
No, so the thing is that pry, you can put it inside your code and it'll provide a stop point in your code with the context of everything you're doing in your code. IRB is just this this kind of playground that lives in your command line. It's can't really just use it to like as a debugger to kind of like stop execution at a point, right? So like for example, I can take this here and I can put it here, and what happens is that when I run this, you see here where it says require pry, bind pry. That means that I've stopped execution of my code. Like all this up here is run. This here has not run yet, and I can verify my assumptions. Verifying your assumptions is like one of your number one tools in order to be able to kind of figure out what's happening in your code. So like I can kind of like insert like the pry at certain points, and that's the advantage of pry over IRB. Also, I think IRB does not have colors. So it's like things are just more readable in pry because you have that color coding. Like do not discount how much colors can help you read and understand your own code or someone else's code.
Perfect. Thank you.
Mm-hmm. Cool. Other questions? Fantastic. So we are at 19 minutes left. What I'm going to do is I'm going to put some questions and stuff in your Slack channel. Cool. What I'd like you to do is at some point today, probably like we're done for this class. You'll at 11 o'clock expect you in Megan's Zoom channel, but like I'd like you to to kind of do this your practice stuff. Also some questions to kind of answer and write down. The questions I'd say like right now do the solo practice section, which is the first half of that image. The questions I would recommend that you do that like tonight after you've had like after the day, so you have some time for this to sink in and you could more easily formulate thoughts into words. I cannot express how helpful it is to kind of write this down in your notebook because it forces you to kind of convert like mechanical knowledge, programming knowledge into like word knowledge. And that is like key to your understanding. Any other questions before we wrap up? Cool, y'all are set. We'll see you at 11 o'clock in Megan's Zoom. And I'll upload this video to YouTube as soon as it finishes encoding.